Welcome back. Today we're going to talk about the scope of inference. Now, inference is what we're going to concern ourselves with in the last half of this course. And inference is going to allow us to make generalizations about populations or cause and effect conclusions. That's actually the theme of this first little part of our notes here. We're going to divide this box in half. So, inference. What we're concerned with in inference is, did we randomly sample from a population, and did we do random assignment of treatments and random assignment in given experiments? And what random assignment and random sample and random assignment allow us to do is to do two very specific things. So if I take a random sample, what that allows me to do is it allows me to generalize about the population. Think about it for a second. If you do a good random sample from a given population, then that sample can be used to apply the principle or to determine, can I generalize this about the population? Whereas if I have a biased sample and it's not a good random sample, then people are going to poke holes in that and say, well, you only sampled with convenience, so how do you know that's going to apply to the whole population? When I get into an experiment and I do a random assignment, what that allows me to do is allows us to make cause and effect conclusions. So, random assignment of given treatments. For example, you have this group, you randomly assign them to two different treatments. Then at the very end, when I bring together those groups and compare the effectiveness of a given treatment, I can then say, oh, this particular treatment, this particular course of treatment allows us to, it causes an increase in weight loss. It causes an improvement in SAT score. Random assignment allows us to make those cause-effect relationships. If not, then it's just going to be us observing some things about given populations, and we could say, well, or given samples, well, we didn't random assign, so we're just kind of watched and looked, and it's more of an observational study. Data ethics has to do with how do we perform these experiments in an ethical way. And a couple of principles to keep in mind. You have to do institutional review. You have to have informed consent, meaning the people have to know, like you have to tell them, this is what we're going to be doing to you. It's kind of, like not necessarily in the specific giving them the treatment, right? But just telling them your informed consent, we're going to be doing a psychological experiment on you, determining whether, flashing lights affect your ability to react to stimuli or whatever it is. And it has to be confidential. And that's to protect all of the people involved. So what we're going to look at in this Check Your Understanding would encourage you to pause here and try this one on your own and come back and listen to the explanation. But what we're going to do in this Check Your Understanding here is we're going to determine what if we can draw conclusions or not, and what does random assignment or random sample allow us to generalize or not. So, when an athlete suffers a sports-related concussion, does it help to remove the athlete from play immediately? Researchers recruited 95 athletes seeking care for a sports-related concussion at a medical clinic and followed their progress during recovery. Researchers found statistically significant evidence that athletes who were removed from play immediately recovered more quickly, on average, than athletes who continued to play. What conclusion can we draw from this study? So, one might think at the outset, athletes who were removed from play immediately recovered more quickly. So we might say, oh, the conclusion is I should definitely pull them from play immediately because they will recover faster. That might be true. However, we do not have random assignment. So we can't draw conclusions. And you might be thinking, well, isn't it obvious? Isn't it clear? It might be obvious. It might be clear. But really what you've done is you have determined correlation, not causation. There's a high correlation of people recovering faster when they were pulled immediately from play. But we can't determine a cause and effect solution because we did not have random assignment. So then the question is, okay, we seem to have these really great results. It seems to me that people who get pulled out of the play contest quickly recover more quickly. So how do we actually experiment with this so that we can apply these results and have a cause and effect relationship? So would it be ethical to conduct an experiment that answers this question? Why or why not? So we can't make inference about the population or with cause and effect. Why not? Well, we can't assign athletes to continue to be injured. You can't assign them to continue to be injured, or you can't assign them to continue to play. Like you can't say, oh, sorry, you got a concussion. You've been randomly selected. You have to stay in the game. So you can't establish the cause and effect relationship because you can't require injured athletes to keep playing. Okay, you can't require them to keep playing. Number 2, can eating nuts during pregnancy help children avoid nut allergies? Researchers studied over 8,000 children who were born early in the 1990s to mothers who were part of the Nurses' Health Study 2. Children whose mothers ate the most nuts during pregnancy, at least 5 times per week, were significantly less likely to develop allergies than children whose mothers ate the least amount of nuts during pregnancy, less than once per month. Okay, so does the study show that eating nuts during pregnancy causes a reduced risk of nut allergies in children? The question is it correlation or causation? And it seems to cause it, but can we establish causation based on the procedure put forth? No, we cannot. There was no random assignment. So we cannot determine cause-effect relationship. So would it be ethical to conduct an experiment to answer this question? No. The babies are receiving the treatment, so no informed consent. Okay, there's no informed consent. The babies are receiving the treatment, right? So you're going to test them for nut allergies, and they are babies, so that is not, we're not able to do that, okay? That's all for inference and data ethics at this point. If you have any